Hello, this is Paul from Foresight Tech. In this lecture, we are going to find the surface area for revolution. Okay, and so first, I summarize all the formula here. We have two type of formula, depending rotating about x or y. For a parametric curve, this is the parametric curve, and the parameter theta is from alpha to beta. So the surface area of revolution, we have two types, we said. Okay, the first, if we rotate it about the x. So do you remember the first formula? 2 pi y when we rotate it about the x. So here is the average circumference, right? The average circumference. And this ds is the length. And the 2 pi y ds is the area of a portion of a cone. Do you remember that? Okay, so that's the original, the old formula. But in this case, for our parametric curve, what is ds? And why we do have a y is gt, right? What is ds? Of course, ds is this, right? ds is square root of dx squared dy squared. That's ds. But depends, if we rotate it about the x, we need to do integration about the x. If we do integration about the x, rotate the x. We do integration, this time is not a integration about the x, okay. Always integrate about the t, right? Because our variable is t. Where is t? So t is from alpha to beta. So this time is different. So how to go to from dx dy to dt is here. See, if you plug dt inside into the square root, and this dt square, we cancel dt square, what do we get? And this bigger term exactly is ds, right? Okay, that's exactly the ds. The second case, if we rotate it about the y, now the circumference goes to 2 pi times x, because the radius is x. Okay, and then plug in ds. ds is this term. Okay, both formula are very similar. Both ds are the same. And the first rotated about the x is use y as the radius, and the rotated about the y use x as a radius. That's all the difference. And I will going to show you one example, see how to use this formula. And be sure to choose which formula to use. And here is the question. Okay, we still have the cycloid, the first arc cycloid for theta between 0 to 2 pi. And this is important. Okay, we have a parametric curve. We take the curve rotating about x, which means the first case, right? So for us, it's the first case. And now we're going to use the formula. What is the formula up here? The first formula. And so S equals this, right? So for theta is from 0 to 2 pi. Okay, and the 2 pi, do you remember? 2 pi y or x? 2 pi y, right? Because this is rotating about the x. Rotating about the x, the radius is y. 2 pi y. The circumference times ds. What is ds? I directly put the ds here. Okay, ds this time goes to dx over d theta square plus dy d theta square, and then d theta. You plug d theta inside and then cancel the d theta, we get a square root of dx square plus dy square. This is ds, right? That's the formula we need. This is the formula. Okay, if we have the formula, now we have everything. All we need to do is do integration, right? That's not new. Now we do integration, plug y, plug the derivatives. Okay, so what do we get? We will get this 0 to 2 pi. 2 pi y is this, plug r 1 minus cosine theta, this is y, and then times square root longer. What is ds? Dx d theta, there, take a derivative to theta is r times 1 minus cosine theta, right? Parenthesis square, okay, and then another is y, take a derivative. This is 0, this goes to sine, so which means r times sine theta square, right? okay, then d theta. Okay, now almost. So now, so can you wait? I'm going to 2, so you can see it clearly. Okay, so now what you do? We have to simplify the square root. And if I do simplification, this r square take out as r square, right? Take all the coefficient out, which means 2 pi r square. Okay, and then the integration is from 0 to 2 pi. Here we left 1 minus cosine theta, and there we left what? You use the Pythagorean. Cosine square plus y square equals 1. Okay, and then here when we simplify, we get this 2 times 1 minus cosine theta. Okay, this is much simpler than the first. So now what you do? The double angle, right? So we did this the last one. This is double angle. Okay, I put it here. We use the double angle identity. Okay, what do we have? We have 1 minus cosine theta. Okay, goes to 2 times sum square at theta over 2. See, and the double angle, and go to the half of the angle, right? The power goes to 2 is okay because we need this. Take a square root that we simplify, and then we put it here. What do we have? So 1 minus this is 2. 2 times 2 is 4. 4 take out is 2. So that goes to 4, right? And this is another 2, so it goes to 8. So you will see this go to 8 pi r square. And then it's 0 to 2 pi. Okay, these ones goes to sine square, and this sine square take a square root. It's positive, so it's a sine. Some square times sine goes to sine raised to the third power. So you can see here is sine goes to third power of the angle at theta over 2, and then d theta. Much simpler than before, right? We can going to simplify a little bit more. So what to do? This angle, okay, we can do substitution. We use the t equals theta over 2. It's okay. So we use this substitute. We do substitution. Like I put it here is what? Is let me see, I put it here. So you use t equals theta over 2. Okay, and therefore we need the what? d theta, right? So d theta is 2 times dt. Okay, d theta is 2 times dt. Plug this basic substitution in. What do we have? So d theta goes to 2. This is 2 times 8 equals to 16 pi r square. And then don't forget to change the limit, right? Original limit is from 0 to 2 pi, and we do substitution goes to 0 to pi, right? 0 to pi. Okay, and this term is sine raised to the third power symbol. Okay, the half angle now equals to t, and the d theta we just did is 2 already put here, so it's d t. Okay, and how to do now? Remember, this is the power of sine and the cosine, and the power this time the power is odd, right? What kind of substitution we need to do? We need to do this substitute. Okay, we need to do this substitution is I use u. Okay, equals the opposite. So sine, the opposite is cosine. Do you remember that? Cosine t, and we learned this from the integral, the trig integral, right? The integration for trig function. There we do this substitution. Okay. Then we do this substitution. We need to separate the sine to here, and the sine square left. Sine square left is 1 minus cosine square. Do you remember that? Okay. So what we need to do is this, and the power square. I'm going to separate it, okay, so we can see it clearly. Separate the sine square. Sine square we change it to 1 minus cosine square, Pythagorean, and then times sine t and dt. See, and if we do this substitution, we do have what? We do have du equals negative sine t and dt, Have you seen sine t dt is negative du, right? Okay, so now we can plug everything in. Is secant p pi r square. Integration. Be careful about the integration. So 0 when u equals 0, theta will goes to negative. We do this substitution. T equals 0, u equals negative 0 equals 1. Okay, here's 1. The t equals pi, the upper limit is negative 1. Okay, so here's a negative 1. Don't forget the limit. And then it's 1 minus u square, of course. So this term from here is negative, right? So times negative 1 du. Now easy, the easiest. This is power, okay, or polynomial. I put this negative 1 outside. So what do we have? And we have a negative secant pi r square. Then the inside directly use the fundamental. This is u, and that derivative. The and that derivative is 1 over 3 u to the third power, and 1 to negative 1. Okay, I wanted to know how to do this. So I plug in to calculation. I get a secant 4 over 3 times pi r square. That's the answer. That's all. Thank you.